Welcome back to the deep dive. So you've handed us this formidable stack of research. It's all focused on the urgent reality of global warming, ice collapse, and what feels like a ticking clock on sea levels.
It is. And our mission today is pretty crucial. We need to go beyond the scary headlines. We want to cut through the scientific noise to really understand the speed, the stakes, and the immediate consequences of the polar melt.
Right, so you can walk away knowing why scientists are so worried.
Exactly.
And the thing that just immediately leaped off the page for me was the speed. I mean, we all know the ice is melting, that's not news, but the sources are clear. It's melting 3 times faster than expected just a few years ago.
That figure 3 times faster, it changes everything. It's not just a scientific measurement. It's an immediate crisis signal. Think about city planners, engineers, insurance markets.
All their models are suddenly wrong.
Obsolete. Overnight. It means we're dealing with a threat that's evolving much, much faster than our ability to adapt to it.
Okay, so let's unpack that. Let's translate those numbers into human geography. This brings us right to what the sources are calling the coastal countdown. Because this isn't some theoretical problem happening in the Arctic. This is a direct threat to massive population centers.
It's a truly global crisis,
Mm,
and it affects profoundly different cultures, different economies.
yeah.
The sources specifically call out Miami, which, faces catastrophic flooding,
Right.
but also these critical ancient cities like Alexandria in Egypt. And then you have these incredibly dense, low-lying regions. I mean, huge parts of Bangladesh.
The common thread there is just vulnerability, but the sheer range of those places should really shock anyone who thinks this is a localized issue. These are global centers of history, of commerce, all facing the same fate.
Absolutely. And when you look at the potential scale of displacement, your focus shifts immediately to the sleeping giant, to Antarctica.
The Antarctic ice sheet, it feels so abstract, so huge.
It does. But the sources, they tie a staggering consequence to just a tiny fraction of it.
The Antarctic trigger, as it's noted here. So what happens if we lose just a sliver of that ice?
If only 10% of the Antarctic ice sheet were to melt, the sea level rise from that alone would trigger human displacement on a scale we've just never seen. It's almost unimaginable.
We're talking millions upon millions of people.
Globally, forced to abandon their homes, to move inland.
10%. It sounds almost manageable until you really stop to think about the enormous volume of ice we're actually talking about. That specific threshold, that 10%, it feels like that's the point of no return for global stability, doesn't it?
It really highlights the leverage of that pull. That 10% represents a locked-in crisis. Once that amount of melt happens, the economic and humanitarian costs are baked in, regardless of what we do after.
So we're not talking about prevention at that point.
No, we're talking about managing a massive forced migration, about the permanent loss of cultural heritage across entire continents.
Yeah.
It just underscores your earlier point. Climate change isn't a future problem. The pressure is already building.
That makes the urgency just palpable.
So if the ice is melting 3 times faster, we have to get into the why, the mechanism. Why is it accelerating like this?
Right.
That takes us to what the sources call the global oven.
This is where we connect the dots between emissions and the ice itself.
Yeah.
And the sources use a great analogy. The planet is becoming trapped like an oven. The heat can't get out.
I think most of us get the basic idea of the greenhouse effect, right? The
Yeah.
gases trap the heat. But what I want to understand is the acceleration. That triple speed is the alarming part.
Okay, so the initial mechanism is the greenhouse effect, just like you said. Gases like CO2 act like a blanket or the glass in an oven. They let the sun's energy in, but they stop the heat from radiating back out to space. That's the warming part.
Right.
But the acceleration, that 3 times faster part, is driven by this terrifying feedback loop. It's called the albedo effect.
Ah, the albedo effect, yes.
Yeah.
Let's really unpack that because that feels like the true engine here.
It is. Albedo is just a term for how reflective a surface is. Snow and ice are bright white, so they're incredibly reflective. They bounce sunlight back into space.
Up to 90% of it. And that helps keep the whole planet cool. But as the ice melts, it exposes what's underneath it, the dark blue ocean or dark land.
And dark surfaces absorb heat. They don't reflect it.
Precisely. Dark ocean water absorbs over 90% of the sun's energy. So the more ice we lose, the more dark surface gets exposed, which means the more heat the Earth absorbs.
Which in turn melts more ice, which exposes more dark surface.
You see the loop. It feeds itself.
It's a self-perpetuating cycle, a positive feedback loop, where the very thing that was solving the problem, the reflective ice, is now gone, and it becomes fuel for the fire.
Yes. That makes the triple acceleration rate suddenly make a lot of sense. The Earth isn't just warming steadily, it's accelerating its own warming.
It's the difference between pressing the accelerator and having the car suddenly floor itself.
A very good way to put it.
Mm.
And we see the consequences of this trapped accelerating heat everywhere, not just at the poles. It proves we're already in it.
Right, the whole atmosphere is just more intense. We're seeing those indicators all the time. Stronger storms, more frequent storms, seasons that are completely out of whack. You get a heat wave in October, a huge blizzard in April.
And, critically, the increasing intensity and frequency of forest fires.
And there's another factor we have to remember for sea level rise beyond just the meltwater. It's the ocean itself getting bigger.
Thermal expansion, yes.
The water literally takes up more space as it gets hotter.
Correct. The water column physically expands. So cities like Miami and Alexandria are facing this dual threat. More water coming from the melting glaciers, and the ocean they're already sitting on is expanding, and both are being supercharged by that accelerating heat.
This is where the conversation turns from, I think, critical to genuinely terrifying. We have to talk about what the sources call the point of no return. This is the concept scientists keep raising, the threshold where our efforts, human efforts, become, well, irrelevant.
It's the point where the Earth's own systems take over. We cross this line when the ice begins to collapse self-sustainingly.
Self-collapsing, we've used that term. But what does that physically look like? What is happening?
This is a key detail that's often missed. It's about the collapse of ice shelves. So think of the huge ice sheets on land, like in Greenland or West Antarctica.
Okay.
They're being held back by these massive floating platforms of ice that extend over the ocean. Those are the ice shelves. They act like enormous buttresses.
So they're physically holding back the glaciers on land.
Exactly. They're like a cork in a bottle, preventing the glaciers behind them from sliding quickly into the sea. But as the ocean warms up, it melts these buttresses from below.
It eats away at their foundation.
Right. And once those shelves break apart and collapse, the massive glaciers on land lose their support. They start to slide much faster into the sea. And the sheer momentum of that sliding ice just perpetuates the collapse further and further inland.
That's the self-sustaining part. The system automates itself.
That's the terrifying aha moment. Human emissions are just the match that lights the fuse. But once that fuse burns down and the buttress is gone, the chaos that follows is just dictated by planetary physics, not by human policy.
And the sources warn that if that happens, even if we stopped all emissions overnight, magically, we couldn't stop it.
We would be utterly unable to reverse the process. You can't turn back time. The collapse would just continue on its own.
So our ability to choose a better outcome just vanishes. We go from being the drivers of the crisis to being, observers of an inevitable geological event?
That's why every tenth of a degree of warming matters so much now. Why every policy delay is so monumental. We are literally in a race against the automation of planetary collapse.
Wow. Okay, so we have this intense pressure, this triple acceleration, and this clear, terrifying threshold. Is there any good news here? Is there still a window of hope?
The message from the scientific community is it's a dual one. It's both realistic and, I think, conditionally hopeful.
Conditionally.
The hopeful part is, yes, there is still time. There is still time to prevent the absolute worst outcomes, specifically to avoid triggering that self-sustaining collapse.
But the other side of that coin is the hardest part to swallow, isn't it? That window is closing fast, and we can't get back what's already gone.
Exactly. Time is a non-renewable resource here. We can slow the future rate of warming. We can prevent those catastrophic tipping points. But we cannot return what has already melted. Every year of inaction locks in a permanent loss of ice, a permanent rise in sea level.
We can avoid a worse future, but we can't undo the damage of the last decade.
That's the bottom line. And that focus on permanent loss just makes the stakes feel incredibly high, especially when you realize the future of the entire world is connected to such a tiny metric.
That is the ultimate takeaway, isn't it? The entire global effort, the future shape of our planet, it all comes down to whether we can avoid the change in just 1 degree of temperature.
That single degree, it's the dividing line. It dictates whether coastal cities survive or are submerged, whether the ice collapse stays within our influence or becomes that automated, irreversible catastrophe.
That's such a powerful and precise mandate for action. So let's bring this all together. What are the key takeaways from this deep dive that you absolutely have to remember?
Okay, first, the acceleration. The ice is melting 3 times faster than we thought. Our old timelines are useless. Second, the mechanism. Remember the albedo effect? Losing reflective white ice exposes dark, heat-absorbing ocean. It's a feedback loop.
And the third.
The irreversible threat. The point of no return is the collapse of those ice shelf buttresses. After that, human action becomes irrelevant. The system collapses on its own.
So understanding this, it moves you past just hearing the scary headline. You now have the knowledge to see exactly what's at stake when you hear politicians or scientists talking about limiting warming to a certain degree.
You know the physical process is driving that urgency. You know the real, tangible costs of delay.
Which brings us to a final thought. If the future of our world is literally defined by whether we avoid that single degree of warming, a marker that separates